So when you hear the term deep learning, what pops into your head? Is it, super intelligent robots, something straight out of a sci-fi movie? Well, what if I told you it's got way more in common with a bucket of Lego bricks? Okay, let's jump in and actually demystify one of the biggest ideas in tech right now.
Welcome to Super Coureva, where we break down AI, technology, and future skills into simple lessons.
Right, first things first. We have got to stop thinking about this stuff as some kind of black magic, because it's really not. It's just a process. A very clever one for sure, but it's a process we can understand, and we're going to break it down piece by piece. You're always hearing these intimidating buzzwords, right? Stuff that makes it sound impossibly complex. But the reality? The reality is built on ideas that are, surprisingly simple. We're going to swap out the sci-fi for some simple math and the idea of a complex brain for, you guessed it, basic Lego bricks. And that is the absolute core idea here. Think about it. A single Lego brick is kind of boring. It can't do much on its own. But you stack thousands of them together in the right way, suddenly you can build a castle, a spaceship, anything you can imagine. Deep learning is exactly the same principle. It's all about stacking incredibly simple little pieces to create something that looks amazingly complex. So let's start small. Let's zoom in on that one single Lego brick. In the world of AI, we call this fundamental little building block a neuron. Now, I need you to just completely forget everything you learned in biology class. In our world, an AI neuron is just a tiny, tiny calculator. That's it. It takes a number in, does some super simple math, and spits another number out. It's the most basic piece in our entire toolkit. To make this feel a bit more real, let's imagine we're running a business, a t-shirt business, and we've got a really simple question. How many shirts are we going to sell if we set a certain price? This is what I like to call lemonade stand logic. It's that straightforward. The input is the price of the t-shirt, the processing is our one little neuron doing its simple math, and the output is the number it predicts we'll sell. Simple, right? But not very powerful. Not yet, anyway. All right, so a single brick is fine, but you can't build a house with one Lego. The real power, the magic, if you will, happens when we start stacking them. Let's see how we go from that simple little calculation to something that is actually deep. Because in the real world, t-shirt sales aren't just about price, are they? Demand is also going to be affected by our shipping costs, how much we're spending on ads, maybe even the material of the shirt itself. All of a sudden, our one brick problem needs a much bigger, more complex Lego structure to solve it. And this right here, this is the huge difference. The old way of doing things would be for a programmer, a human, to sit down and try to write out all the rules by hand. If the price is low and we spend a lot on marketing, then the demand is high. The AI way is totally different. We don't write the rules. We build a system that figures out the rules all by itself. And the way it does this is with something called a hidden layer. It's just a bunch of our Lego bricks, our neurons, that we sandwich in between our inputs and our final answer. You can think of it like a little team of detectives, where each one is assigned to look for different clues and connections in the data. And this is where it gets really, really cool. Look at what this hidden layer might figure out on its own. Maybe one neuron starts looking at price and shipping costs together, and without us ever telling it to, it learns the abstract idea of affordability. And maybe another neuron combines the marketing budget with the shirt material and comes up with its own concepts of perceived quality. It's discovering these ideas completely by itself. Okay, so that leads us to the most mind-bending part of this whole thing, the real ghost in the machine. How on earth does a pile of simple little calculators actually learn? Exactly. This is the big question, isn't it? How does it know that combining price and shipping is even a useful thing to do? How does it just invent a concept like quality out of thin air? And the answer is, well, this is what makes this tech so powerful. We don't teach it any of these concepts. We don't give it any hints or clues. The network literally develops its own way of understanding the problem. It builds its own internal logic. The way it learns is actually pretty simple in concept. Step 1, you just dump in a ton of data, thousands of past examples of t-shirt sales with all the inputs. Step 2, you also give it the answer key, the actual sales numbers for all those examples. Then step 3, The network makes a guess, checks its guess against the answer key, sees how wrong it was, and then nudges all of its little internal calculators, just a tiny bit. And it repeats that process millions of times until its guesses start getting really, really accurate. And here's the kicker. Because it's not starting with any of our human biases or assumptions, it's totally free to find connections that we might completely miss. It might discover some weird, subtle pattern that a human analyst would never, ever think to look for.
So now that we've seen all the individual bricks, let's put it all together. Let's think of this whole thing as a simple recipe you could follow. Step 1 is your ingredients. You need a massive amount of data, both your inputs and the correct answers. Step 2 is your cookware. You design the structure, that stack of Lego bricks or neurons that's going to process everything. And step 3, the cooking itself. You just feed the ingredients into the cookware and let it run over and over until the network has figured out all those hidden relationships for you. And honestly, that's it. The end result is what we call a trained model. It might seem incredibly intelligent, but as we've just seen, it's not magic at all. It's just the final product of a very clever but very understandable process.
Which kind of leaves us with one last, really fascinating thought to chew on. If this technology is basically a pattern-finding machine that can see connections that are invisible to the human eye, the real question isn't just about how it works anymore. It's about what completely new, undiscovered patterns about our world it's going to find next.